Today the topic is remote 3D printing, and I'm going to show you my guide for configuring a webcam in OctoPrint step by step. I'm Leo and this is my channel, Leo Tech Lab. If you don't know it yet, take a look at the introduction video. Let's go! Okay, so in terms of requirements for this guide, you will need a computer with OctoPrint already installed. If you don't know how to install OctoPrint either on Linux or on Windows, take a look at my installation videos. I have videos for both of them. You can check them out in my description below. I'll leave links to them, okay? Next, you will need a USB webcam and, of course, some time and patience. Okay, so video sources in OctoPrint. Why do we need them? There are two main reasons why we want to add video sources to OctoPrint. Remote monitoring, so that we can take a peek at our printing remotely, which we can do here in the control tab, okay? In this case, I don't have any webcam set up yet, so I don't see anything, but we would be able to follow the print in real time over here, and also creating time-lapse videos for our prints. That's the other main reason why we want to add video sources to OctoPrint, and that is this tab right here, time-lapse. Of course, currently we don't have time-lapse configured, okay, but if we did, we would be able to access our finished time-lapse videos here and download them, okay? Okay, so for remote monitoring, OctoPrint just embeds in this window a URL of a direct stream from an external video source in its web interface. So it doesn't do anything else with it. From what I've searched, the most common stream that is used for this is MJPEG. Which literally stands for motion JPEG, or a continuous stream of JPEG images. Okay. Regarding the time-lapse videos, OctoPrint makes use of a URL that returns an image so that you can put them together using the FFmpeg application and produce a final time-lapse video that is basically all the snapshots stitched together. Okay. From what I've searched, the most common format used for these images is JPEG. As such, in order to be able to remotely monitor our prints over here and to create time-lapse videos from them that we can later download from here, we will have to get two URLs, one for the MJPEG video stream and one for the JPEG snapshot images, okay? So we'll deal with how we can get them in a moment, but I want to show you where we can configure them. So here in the settings tab, we can go to the webcam section, and here we have webcam and time-lapse. And here in the webcam, here is where we'll input the stream URL to enable remote monitoring in real time. And down here in the time-lapse recording section, we have the snapshot URL, okay? So this is where OctoPrint is going to get its snapshots from the current print. And here is the FFmpeg application path, okay, so that OctoPrint can use this application, this video encoder, to stitch up all of these snapshots into a final time-lapse video. Okay, we'll take a look at how we can configure this in the next chapters. Okay, so now that we know what we need, let's get to work. In this scenario, which will most likely be the most common, we have a USB webcam connected to our OctoPrint server, and it is pointed at our printer, ready to collect images. But first, we have to create two URLs from it, one for the MJPEG video stream and one to get JPEG snapshots. There are several applications for this purpose, and on Windows, a very popular one is Webcam, which actually comes packaged in the official installation of OctoPrint for Windows. Okay, so as such, it's the one we're going to use in that scenario, and I can show it. I can show it here. So let's search for Webcam. It's this one right here. Okay, so it's this free software. And as you can see, what is Webcam? Short for yet another webcam software. Webcam software for Windows written in Java. Keep it simple, but include all the usual features. Okay, so which features are these? Okay, so here we have video streaming, image snapshots, built-in web server, motion detection, FTP upload, etc. So we're going to use the first three. Okay, video streaming for our remote monitoring in real time, and image snapshots to be able to render our time-lapse videos. Both of them will be served by the built-in web server that comes with Webcam. Okay, so this is an all-in-one package for what we need. It has other features, but we're not going to use them in this setup. Okay, so that's Webcam on Windows. So regarding Linux, in my OctoPrint installation guide, actually this is the instance that resulted from that guide. I use the approach of installing it via Docker, and fortunately the OctoPrint Docker image itself includes an application similar to Webcam. It's called MJPEG Streamer. Okay, so that's the one we're going to use on Linux. Okay, so next let's handle both operating systems one by one. Okay, so we have our Linux OctoPrint instance based on Docker Compose. Okay, so this is the same instance that was set up using my installation guide. If you haven't checked it out, you can. The link is in the description. So basically what we have to do to set up our webcam here is number one, stop this running container. Number two, change our container configuration by editing the Docker Compose file. And that will allow us to enable both the USB webcam and the MJPEG streamer application. Okay, so that it generates those two URLs that we need. And finally, spin the container back up again. Okay, so let's do that. So first of all, let's just check if our USB webcam is correctly configured in our Linux machine. So I'm going to open the terminal. I'm going to use LSUSB, and that is going to list all of my USB devices in this computer. And okay, I haven't connected my camera yet. It's not present here, so just give me 1 minute. I'll be right back with the connected camera. Okay, so I've just connected my USB camera, and I'm going to LSUSB again, and there it is. So this, by the way, is a perfect example how you can find out which one of these devices is your webcam, because over here we have a new entry in this list. Okay, the Microdia H2 live camera that wasn't present here. Okay, so you can just unplug and plug your camera back in while performing LSUSB before and after you plug it in, so that you can see which of these lines is added to the list, and that will be your USB webcam. Okay, so we have the device here. It's on bus USB bus 3, and it's device number 5. Okay, but now we need to check if the device, although it is correctly connected to our Linux machine, if the device driver is working properly with it. Okay, because without the device driver, Linux cannot really interact with the webcam. Okay, how can we check this? Well, easily we can, at least the easiest way for me is just to ls the /dev directory, which is the devices directory for Linux, And so this contains basically your mounted hardware, so your hardware that is associated with a device driver. Okay, it's not exclusive for hardware, but hardware stuff that you need to interact it with should be here. Okay, and so we're going to find, or try to find, video 0 or video 1 files. Here they are. Okay, so video 0 is actually the one we want. Okay, if you don't have a video 0 or video 1 or video something, okay, files, your Linux machine is not loading the device driver properly. Okay, but in this case it is, so we're good to go. Next, we need to stop our running container. Okay, let me just maximize this so that you can see better. So I'm going to sudo docker. Oh, before this, let's just check our running container. So ps sudo docker ps lists our current running containers. Password, because I'm going to execute this as an administrator. Okay, so this is our current Docker container, which is running. Okay, so let's stop it. In fact, we're not going to stop it, we're going to destroy it. Okay, and this is because if we just stop the container and then we change the Docker compose configuration, when we start it up again, it won't assume those changes. We need to destroy it and then to spin it back up again in order for it to assume the changes we did. Okay, but that's not a problem, because if you watched my previous video on how to install OctoPrint on Linux, you know we're using something called volumes. And a volume allows us, in this case, to maintain the configuration state from our OctoPrint instance, even if you destroy its container. Okay, so its configuration, like the printer setup and printing configurations, are all safeguarded there. So we can safely destroy this container and spin up a new container, because it will point to the same volume, and so it will load the same configurations as the previous container. Okay, so let's do that. Let's destroy this container. Sudo docker compose down. Okay, so this destroys the container. Oops, no configuration file provided. Of course, I'm not in the correct directory, so I'm going to go to my OctoPrint directory, and inside here I have my Docker compose file, my configuration file. So over here I'm going to execute the same command, and it should destroy it. It's done. Okay, let's just check the sudo docker ps. It's gone. And let's add the -a flag for show me all containers, running and non-running containers. And the only one we have which is stopped is the hello world container. So no OctoPrint containers here. We have successfully destroyed it. Okay, now that we have destroyed our container, let's just edit this file, the Docker compose file. Okay, you can use any kind of editor you want. You can use like Nano, which is a command line editor. Okay, so I'm going to just use the regular text editor from Ubuntu in this case. So I'm going to open the file explorer and going to go here to OctoPrint and just double click on the Docker compose file. Okay, so here we have our Docker compose configuration file. I'm not going to go into detail about this file. Okay, if you do want more information about this configuration file, check out my previous video on how to install OctoPrint on Linux. Okay, but what we need to change here is basically enable our webcam device, which is this line over here, the /dev/video0. Okay, so we just want to uncomment this line. Okay, this one here, the first one, is our 3D printer, and this one here is our webcam. And so what we are doing is before the colon we have our host operating system file system. Okay, so in this case we're telling that our Linux machines /dev/video0 file will be linked to our internal container file system, specifically to the /dev/video0 file. Okay, you could change these names, but in this case it's not a good idea, because over here on the left, well, you have to use exactly the file name that represents your webcam, and in our case it's video0, as we've just seen. In the right side you shouldn't really change this, because both OctoPrint and MJPEG Streamer are configured to look for /dev/video0. Okay, so if you change this, they won't work out of the box, and you will have another set of problems that you really don't want to have. Okay, so just leave it as it is. It's perfect the way it is. Besides this, we also need to activate the MJPEG Streamer application, and in this case we do it by uncommenting this environment variables section, and by uncommenting this line, which will basically create this environment variable and assign it the value of true. And basically what this will do is to let our container know that it should enable the MJPEG Streamer application, and so it will start providing those two URLs that we require, the one for MJPEG streaming and the one for JPEG snapshots. Okay, so MJPEG Streamer on, USB camera configured, we're good to go. So let's just save this and spin our container back up. Okay, so let's spin up our container. Sudo docker compose up. Okay, so create it back up and run in daemon mode. Okay, so in the background, that's what this -d stands for, and it's done. Let's just check our running containers. Perfect. So created 6 seconds ago, up 4 seconds, it's working. Okay, so now that, let's just refresh our web browser, and here it is, it's running again. Okay, don't mind this connection problems, because currently I don't have my 3D printer connected, but really I don't need my 3D printer connected to test out the webcam scenario, so that's fine. Okay, let's go to the configuration area just to check that everything is okay. Webcam and time-lapse. Okay, so here we have the stream URL, and here we have the snapshot URL. Okay, as you can see, these are already filled out. That's a cool thing about this. Oops, sorry, enable, yeah. That's a cool thing about this OctoPrint Docker image, is that it's already set up and good to go exactly as it is. Okay, so this is a relative URL because this actually is just embedding the source in the web interface, in that control box that you saw, that black control box that you saw. So basically this is referring to our current machine, which is actually responsible for streaming via MJPEG Streamer. Okay, that's why this is a relative URL, but you could also put a fully qualified URL here if your source is elsewhere. Okay, in this case it's coming from this machine, so a relative URL, that's fine. And down here, okay, this is the snapshot URL, sorry. So this actually is a server-side function, so it really needs the fully qualified URL. It says right here, needs to be reachable by OctoPrint server. Okay, so this is not a URL to be served in the web interface. That's why you need the fully qualified URL, even if it's the current machine that is hosting it. Okay, but we can just go ahead and test this, and it's working perfectly. Okay. Just imagine this is the 3D printer. Of course it's not, but you should be able to see it perfectly. Okay, so this is the remote stream, okay, for the remote monitoring scenario. And down here we can just click test and take a snapshot this instant. Okay, let me just change my hand to a great sign or to a thumbs up. Perfect. So it's working perfectly. Okay, this means that we can go over here to the control tab and voila. Okay, remote monitoring done. And over here to the time lapse, you can now configure the time lapse either to timed, okay, which means that every X amount of seconds it will take a snapshot, in this case 10 seconds, or you can also do it on Z change, meaning every time your 3D printer changes a layer, okay, it prints from bottom to top. So every time it finishes a layer and hops over to the layer above it, it will take a snapshot, okay? But that's out of the scope for this guide, okay? But after that, after you configure this time lapse here, you can just tell your printer to print, and it will actuate accordingly to the configured setup here, and it will provide you with time-lapse videos down here so that you can download it and consume it like that, okay? So as you can see, very simple way of configuring a webcam in OctoPrint in Linux based on Docker. Okay, that's it. And that's it. I hope this was useful to you. Please leave your feedback and share your ideas and opinions in the comments. If you want to stay up to date with the next videos, you can subscribe to the channel and click on the like button. Thank you, and I'll see you next time.